Okay, so now that we've got our radians and we know where they are in the circle, we want to talk about the exact values at those points. Okay, when we're talking about exact values, we come back to, or we actually come to, this guy called our unit circle. So he's called our unit circle because we are imagining we've put him on a graph and here's a circle that only has a radius of 1. So that would mean all our intercepts are 1s or negative 1s. So that's why he's called the unit circle, because 1 is a unit. And we break him up into 4 quadrants. That's what each of these little sections are called. And we're going to talk about the symmetry that happens in those in a bit. But to start with, I just want to talk about the first quadrant. Okay, so we're imagining we've graphed this. So this is 1 up here, and this is 1 over here. So we can break this up, 0.5, and actually graph it. So what we want to talk about is the different radians and how they look on this graph. So pi on 3, pi on 4, and pi on 6. Oh, that line was a little crooked. You should be right there. Okay, so when we draw in a line at an angle, we are talking about an angle down here. So my first triangle has an angle of pi on 3, 6. Pi on 6. Because if I break my circle up, there'd be 6 of them. My next one has an angle of pi on 4. And my next one, pi on 3. So those are the 3 angles that I drew in. I then turn them into right angle triangles because that makes it maths that we can actually work with. These right angle triangles are going to be really handy. So if I just think about one right angle triangle, this is pi on 6. I want to know this coordinate up here, x and y. I want to know what values it's actually hitting when I graph it. So if you did this accurately on a piece of paper with grids and stuff on it, you would see that our y value is 0.5 and our x value is 0.866. Alright, but we don't want to talk about in decimals. We want to talk about in exact values. And really nicely, they actually come out as root 3 on 2 and a half. I know root 3 on 2 doesn't look very nice, but that is the number it exactly is, so that's the number we're going to talk about. So why are these important and how does it relate to trig? Well, if we think about our triangle, pi on 3, angle. Alright, so we know the radius of our triangle is 1, which means the hypotenuse for all of these triangles is 1. So if I tried to find this side down here, my x length, well, to do that, that's my hypotenuse and my adjacent. And what rule is the hypotenuse and the adjacent? It is cos. So I can find that cos of pi on 3 equals my adjacent, which is the x value, over my hypotenuse, which is 1. So then if I times both sides by 1, I basically get rid of it. So I know cos of pi on 3 equals x. So in this triangle I've just created, if I was to find the x side, that's like finding cos of that angle. Alright, so what about if I found the y length? So the value of y. Well, that's the opposite. So sine of pi on 3 equals my opposite, which is y over my hypotenuse. Once again, if I times both sides by 1, I get down to just sine of pi on 3 equals y. So if I know the height of my triangle, that is the sine value. These should have been pi's on 6's over here. in my own head. So what we've just learnt is that if we're working the triangle, if we find the adjacent side, that's the same as finding the x length on my triangle or finding the cos. So x, cos, and adjacent are all the same thing. Y, sine, and opposite are all the same thing. So that's really important to note. So that gets me the exact values. So over here in this quadrant, I can see that if I stuck it in my calculator, my exact value would be root 3 on 2.5. My exact value for this one is root 2 on 2 and root 2 on 2. My exact value here, half, root 3 on 2, and that's it. What about down here? What's my exact value for x and y there? Well, if I graph it, x is 1, y is 0. So that tells me that if I was finding sine of 0, for example, that equals 0 because that is my y value. So if I found cos of 0, that would equal 1. The other ones that we haven't done up here or here, x is 0 and sine is 1. Okay, so they're the exact values and they're the important ones to note. But how does that all fit into my circle? Now we're going to talk about the symmetry of how these angles work. So we're going to keep working on the pi on 6 radian. Okay, so I know that because it's pi on 6, I can split my whole triangle up into, my whole half up into 6 sections. So that's pi on 6. Now that triangle is symmetrical over here in my second quadrant, because we can see that is the exact same triangle. I've just flipped him over. Alright, so the really nice thing about that is I already know the length of that triangle. It's root 3 on 2. And I already know the height of that triangle. It's half. So my points in that quadrant are exactly the same as over here, but with one little difference. Is x negative over here? It is, because we've gone from 0 and we're now going down our axes. So sine is exactly the same, it's still positive, but x is now the negative. So my values are negative in that quadrant. Cool. So then there's two more. We've got another triangle, which once again, pi on 6. So the values are still going to be exactly the same. That's 3 pi on 2, root 3 on 2 and a half. But now x is negative and y is negative. So both of these answers are negative. And then I have one more triangle. Oh, drew him really poorly. So once again, because it's pi on 6, that's going to be root 3 on 2 and a half. But now x is positive, y is negative. So I've got negative a half and positive root 3 on 2. So that's how it changes. So both of them were positive here. So I have a positive sine and a positive cos. I have a positive sine over here and a positive cos over here. Neither of them are positive down in that bottom one. Okay, so that's really cool. That's how symmetry works. The exact values are the same in every quadrant. It's just their positive and negative change. We also want to be able to talk about what angle that is. So if this is pi on 6, what angle is this line at? Well, I can count. It's 1, 2, 3, 4, 5 pi on 6. That's my angle. Or I can think about it as I made it all the way round to pi and then went back pi on 6. So this is pi minus pi on 6 to get me that full angle, which is 5 pi on 6. To get me the full angle all the way from 0 round to here, it's going to be pi plus pi on 6, which is 7 pi on 6. So that's the angle. So then, rather than drawing it the whole way around or counting how many pi's on 6s it is to get here, I can just think, well, I was at 2 pi on 6. I was at 2 pi. I went back pi on 6, so that's 2 pi minus pi on 6, which is 12 pi on 6 minus pi on 6. So I know that angle to get me all the way around to here is 11 pi on 6. And that's how our symmetry works. But we also need to talk about tan. So, the deal with tan. We know that tan of theta equals opposite on adjacent. So I want to be able to figure out how that relates to my triangle. Well, if I think about it, the opposite side of my triangle is going to be this one. It's going to be my y. And the adjacent side of my triangles is going to be this one. It's going to be my x. What else do I know about x and y and opposite and adjacent? I also know they can be called sine and cos. So this is sine theta on cos theta. So that's what tan equals. So tan is also a tangent, so it's actually the value of that guy. But we're not going to talk about how he works specifically, we're just going to talk about his value. So tan theta. So if I wanted to know the tan value at all of these points, I would need to do a division. So tan of pi on 6 equals my sine value, so a half, divided by my cos value, so root 3 on 2. Alright, so I'm working with fractions, so don't forget we keep, flip and change. Then I can cancel some numbers, so that gets me 1 on root 3. But then I don't like surds on the bottom, so I'm going to times that by root 3 on root 3, because that's like timesing by 1. So my answer for tan of pi on 6 is root 3 on 3. And that's my answer. So tan of pi on 6 equals root 3 on 3. So we now know sine, cos and tan in our first quadrant. But what about tan of 5 pi on 6? Okay, well he's going to be the same number, but I now have a positive divided by a negative. So he's going to be a negative value. Down here, once again, this is now tan of 7 pi on 6. I'm still going to have the same numbers, but I have a negative divided by a negative, which is a positive. So that's that one. So down here we know this is positive tan. Over here, tan of 11 pi on 6 equals root 3 on 3. But now I have a negative divided by a positive, so he is negative. So we now have all of the values for tan, sine and cos for the pi on 6s. You can do the same thing basing it off these numbers. And the really nice thing is those numbers are on your cheat sheet, okay? You don't have to remember that sine of pi on 3 is root 3 on 2. It's on your cheat sheet. You then need to be able to work with the symmetry and figure out what's positive and negative. And we do that by using the cast diagram. Okay, so if you can figure out that you are in the first quadrant, all of your answers will be positive. If you figure out you're trying to find something in the second quadrant, only sine is positive in there. So if you were finding cos of something in the second quadrant, answer is negative. Down in the third one, only tan is positive. Fourth one, only cos is positive. And that's how our cast diagram works and our exact values. So don't forget to find them on your cheat sheet so you know where they are.